So today I'm going to talk about FFI. Anyone already know what is FFI? No one. You know FFI. Sorry?
Go live?
No, FFI, I say. Foreign interface. Yeah, that it is. So it means I'm going to make the Go application, Go library, that communicate with Flutter application. That's what I'm going to do today. So yeah, so everyone already know me. So I am full stack developer at Unity, and I'm GD Flutter, recently joined, like Billy introduced, and GDG and FlutterMTL organizer here. And then I just put something different, Scrum Master. So if you want to talk about the project management or Scrum, how to manage your team and so on, I'm here there. So it's welcome to speak with me about that. So if you want to connect with me, just QR code and LinkedIn. Right, so here's the agenda. So we are there, introduction, and I will start with my motivation, why I did it, and I will give you a small introduction about FFI, and then how to compile the Golang application, Golang library that can be loaded in your Flutter application, and how to use it, and we'll go to the conclusion or Q&A. All right, so motivation. So I put many things there. Golang is powerful language and so on, performance and then lightweight and so on. Flutter is, you can make a beautiful application and so on, right? We just want to mix these two power to make the better application. Is it true? I don't know yet. The real reason behind was one of my colleagues was making Golang application, and then he decided to use web UI. So I want to show him, now you can use Flutter. So that was the reason behind I tried to study on that. All right, so why people use Golang? So with Golang, you can make a cross-platform application. So something similar to Flutter. So Golang code can be compiled into many different architecture, x86, ARM, or also different OSs, so Windows, Linux, macOS, or whatever, right? And even better than Flutter or Dart is that they also have cross-compiler, meaning that you can compile macOS application from your Windows. You can compile Windows application from even Mac. That's another power of the Go. And what it can do with the Go is, the really shining point of the Go is the fast compilation. So Golang, you change your code, even if it's big or small project, the compile, the speed, you cannot compare with any other language, actually. So Google, they made the Go to optimize their build process. That's what I heard before, like 10 or 20 years ago. And the other thing is that Golang is lightweight, and then it's highly scalable, and they're really performant. So how they do that? They have the special concurrency feature called Goroutine and channel that makes it Golang application easy to manage all different threads, and then you can make it performant application. Now, the Flutter. So I didn't do survey yet, so who knows Flutter?
Nobody.
No, we have some people, I see. Okay, who did actually Flutter coding before? Even Hello World. Okay. Who did the Golang application? Okay, a few people, that's nice. Okay, so it looks like a little bit the advanced topic, but maybe it's not, because I'm not gonna go too deeper. But today now I'm talking about just Flutter. So just remind you who doesn't know Flutter, right? So Flutter, cross-platform. So you can use the Dart code, can be compiled to many different platforms and architecture, Android, iOS, web, and desktop, Linux, Windows, right? Flutter provides nice tooling for the developers, meaning that, let's say, the famous one is hot reloading, right? So you just change your code, and then it instantly loads in your simulator, in your real device, just like instant, right? So when you're making UI, it's super easy, super fast, You can easily debug your application. Like Lens already introduced custom renderer. We can control every pixel in your screen because the Flutter has its own rendering engine called Skia before. Now it's Impeller for iOS. Impeller is going to come for Android very soon. So you can be creative as much as you want, and then you can make your application beautifully. That's it. So, so I introduced Golang, Flutter. Do you think it's a good mix now? All right.
Is it Gemini feature?
No, no. Yeah, it's a slam dunk. I don't know if you know this. Yeah, I just put the meme, like a meme, Flutter and Golang there. I made it. All right, so let's talk.
Why not just inject Golang script into Flutter? Why is this approach better?
It is technically it's injecting, but here is I want you to say collaborating.
Okay.
So that's why I just put this image. But yeah, I mean, technically, Flutter, I mean, you're gonna see it later. But what I'm gonna do is I'm gonna load Golang library inside of Flutter application. So actually, Flutter application is just using it. So it's kind of injecting, right?
So essentially, you're making it native to.
Yes. Yes. So now it's time to talk about FFI, so foreign function interface. So what does it mean is, so let's say you have two different languages, but you want to use the feature of another language. Let's say you want to use OpenCV or the machine learning library written in C or C++, right? And then you want to use it in Flutter. You need to use FFI because you want to communicate with it, right? So it's the same thing. Here, I'm going to do the Golang FFI. So I'm going to compile Golang application into native code, and then I will load it in Flutter application. So that's what I'm going to do, and that's the FFI here. So in Flutter, it supports the FFI, whatever the language, can have C, the interface. So meaning that once you compile, and then if the library can communicate with C language, then you can use it. And Golang has the feature called CGO, so you can actually have the C interface in the Golang application. So when I compile it, it's compatible with the C application. So that's how I did it. So meaning that C++, Rust, or Go, or any other language have C interface, you can actually load it in Flutter application. So I said Go, but this talk is not only about the Go. So you can do whatever the native library, you can load it in the Flutter.
What
Yes.
are the restrictions on the FFI? Where will this break? Which languages can we not use as?
Let's say Java. You cannot use it because Java you cannot compile into the native, right? C++ you can compile into native. Rust you can compile into native. I mean, Rust I said, right?
Solidity will work or not?
It works. C++, Rust, Golang, that's a perfect example. You can use it in Flutter. But you cannot do that with the Java. But instead, Java, there's another interface. Maybe we can talk about it later. But there's a JNI interface so that it makes it your Dart application communicate with Java. So it's different communication channel. But today it's going to be FFI, which can communicate with native library. Yeah. So how to use FFI in Flutter? Actually, I'm going to come here. So in Flutter, they provide template to make the plugin application for native applications. So you see the Flutter create command to create your project. And then I just indicate different platform, Android, iOS, macOS, Windows, Linux. I put everything. And then you will choose template or plugin underscore FFI. So they already provide the template. But this one is based on the C application. So you have the C, the library you're going to build it, and then you're going to load it from your Flutter application. So yeah, so once you create the project, you will see, do you see it? Is it big enough? So you see there the folder example folder. That is actually example application that loading the library. So basically, this whole project is a library project. So there's an example project that loading the library, and then there's src folder. You see there's a native underscore add.c and the header file. Who did a C before? One? Only one? Okay. C++? Okay. So not many people? You did? All right. Yeah, so it's a C. Don't be scared. So I'm not going to explain everything about the C. Don't worry. So what they do is they use a CMake list file. So they're going to compile C into the library, and then they're going to have the binding. So binding means you can bind the C function into the Dart code. So you can easily just call the Dart function that actually calling the C function. So this code is going to be automatically generated, and then this Dart file native underscore add, this is actual library that we're going to expose it to the example project. Okay? So I'm going to show you a demo. Right. So as I said, this command, I'm going to just use it. I'm not actually going to run it, though. So I have folder. So I have demo folder. When I run this command, then it will create native underscore add project. Okay, now I need to make it bigger. Oops. Right, like I said, there's an example folder, which is Flutter application that's using this library, and the library for lib folder that has the bindings.
We have a question on YouTube.
Yes.
Can we expect it to work for web app with WASM composition?
So I'm not cover this topic today, but I have really good example that he may try out. I will show you at the end of the presentation.
Show Icarus.
Sorry?
Show Icarus.
All right. Oh, actually, I need to create the project because I already converted it to the Golang. Okay. Sorry about that. I will just create the project. So example project, and then there's this src folder for the C application. So what I want to show you is only this. There's a C function that, taking the integer number, A and B, and then it will just sum it and then return it to the integer. And this one I'm not going to cover today, but it's a really simple application, and header file is just for exposing the function we wrote in C, and then you will see later. And the other thing is I want to show you is Jhin. I'm going to show you later. And this one is actually the format automatically generate the bindings. So C and Dart language binding will be automatically generated by this script that we're going to use later. So let's see. We can try to learn it. Okay. Yeah, I'm going to run it on the iOS device. All right. It takes time. But it's just really simple application. There's only one screen that's showing you I am sending two number, and then you will see the result. But actual business logic, like you see, is written in C language instead of Dart. Okay, takes time. So in the meantime, maybe I can show you some code. Oh, did it work? Yeah, so you see, here, I'm passing 1 and 2, and then the return is 3. So this is actually done in C language in here. So this called actually the sum function. And I can show you the example app. It's also really simple too. So some result in Dart, and then calling the native underscore add function in Dart, that result, and then we just printed the result in the UI. That's what we are doing. So yeah, I will show you the binding later, and then we can go back to the presentation. Yeah, so they already provide the template, so actually it's easy to do it. So if you want to use C library, then there's already interface, everything written there. So you just need to add your code in native language, and you can just use it, okay? But now, what you want to do is actually, I want to use Golang instead of C, right? So we need to start create Golang project, right? So when you do the Flutter create something, that you create a project, and then you start from there, right? Golang, you can do Go mode in it, and then you put the module name. Then you're going to create the go.mode file, which might be, in Flutter, might be equivalent to the pub spec file, something like that. OK. And then we're going to write actually the Go code. So I didn't put any complex Go language syntax here. But this one is actually not exactly look like Golang, because I'm using C-Go interface here. So you see here, there. So when we are exporting this sum function, I'm using a C type. I'm using the C type for this A and B, and then return type is going to be also C type. So C int. So to use that, I'm importing the C. And in Golang, in C-Go syntax, if you want to expose this function, you can use export sum. Then when you, I mean, this command is actually, you need to put it in. It's like the annotation in the Java or Dart. So then it will compile, and then it will automatically create header file and the library based on that. That's what it does. So yeah, I explained everything there. Yeah. So now you need to compile it. So we wrote the Golang, but you need to compile to run in Android application, Android, the platform, or you need to compile it to run on the macOS or iOS and so on, right? So my example is going to be how to build the library for Android. So there's a script. You don't need to remember. I'm going to give it to you. That's what I studied, how to actually build Golang library to run on the Android devices. So what's the important thing here is you need to build two different the compile. One is AMD64, the other one is x86-64. So Intel and then Silicon, you can just easily, I mean, ARM or Intel. But I'm not compiling the x86 because most of modern devices are all 64-bit, right? So in the code, in the script, what you need to see is here and there. So I'm compiling two different times. One is for x86-64, and then the other one is ARM64. Right? Only difference is the architecture. So I'm putting AMD64 there. And actual command is there. Go build minus build mode C shared, and then you put the output folder. So what it actually does, it will compile the SO library, which means dynamic library that you can load in your application. And I'm putting this SO file under your Android folder. So you see Android output is actually Android SRC main JNI libs. So I don't know if anyone have done for the NDK project in Android, the SO file is going to be stay in there. So when you package it, that will add the SO file in your package. That's what it does. So same thing here, so, but the ARM64. So another thing, just compiling another one. And then put into the other folder, ARM64-V8A folder. That's only different. Once you compile it, and then once you have this in your Android project, then now you can load the library, libsum, we just built it, in your Dart application. Then now you can call the function. That's what it does. So I'm not going to cover for the iOS build, but just like some summary that I did for the iOS when I do the study. So there's some differences. Android supports dynamic library, but iOS only supports static library. So you have to compile it to .a library file. That's what first thing you need to do. And then you need to compile more platform, AMD64 for simulator, AMD64 for simulator, if you want to use it in your simulator, right? And then ARM64 for actual iPhone devices. Same thing, I don't build for the x86 because there's no device running on the x86 anymore for the iPhone. And the other one is the LiPo. So it took some time to understand what it is. But basically what it does is merging these two libraries into one library. So for the simulator, I'm going to have one library that can be run for both. And I need another merge. So making as package, library package, X framework. So I'm going to merge all the library I compiled into the one package. So this looks complicated, but I wrote everything about that in my article. And then I also have example. So you just need to run the script that I wrote, then it will do everything automatically. All right, so now let's talk about how to actually use it in Flutter app. So first thing is make the bindings. So what is the binding I said is, let's say you want to call Dart function, not C function, right? So the binding is the once you call Dart function, that will automatically call the C function. That's what it does for the Dart binding. So to do that, like I showed you before, we are going to use Jhin. This is another package the Dart team is providing. So you need to write YAML file, something like that. It's easy. So you just need to put the output, and then you need to put the header file, which has the function, the symbol. So he knows that how it looks like your library, right? So once you have it, you're going to just run flutter pub, run fgen --config fgen.yaml, then it will generate the bindings under the lib folder. That's it. And then now you're going to use in the bindings in your actually Dart application. So like I say, first one we need to implement is actually the function. So bindings.sum, that is actually Dart function in the binding that actually calling the C function. Okay? And this is the way how to load the libsum library. So I only put the platform Android and Linux here because platform Android and Linux can do the dynamic library loading. So that's why I have it. If you have the iOS the library, you need to add one more line, maybe 2 lines. Okay? And if it doesn't support, then we're going to make it crash. And once we do that, then you can use this sum function in anywhere in your Dart application. So easy, everything is done. Okay? So now I'm going to show you some demo with the Golang application. I think I already have it open. Not this one. Yeah, this one. Do you still see it? Or zoom it more?
It's okay.
Like that? Okay. So Golang. So when you do the Go mode init stuff, it generates this file. You can just write it yourself. So what it does, just define the Go module name, and then the Go SDK version that you're going to define. And then normally you can put the dependencies here for the Golang. But I don't have any dependency to add. And there's a sum Go file, like I show you. So it has the sum function written in Go, but interfacing the C. And this header file, you don't need it, actually. So once you compile it, this header file is going to be automatic. It will be automatically created thanks to this part. Oh, not this part. We are exporting here, so it will automatically generate a header file that you can use it for your Fusion. So once we have it, we have the Fusion YAML. So I am feeding the header file that I compiled. And then once I run the Flutter pub, run Fusion, and then passing this Fusion YAML file, then it will generate the bindings in Dart under the library folder. So like you see here, this one, so like, this is the same name, generated bindings, .dart. This one is generated. You don't need to understand everything, but what you want to know is the sum function is there. And we will use it in Dart. So this looks complicated. So actually, I have another project that must be simpler. So this is the actual library that I am adding in my library project, plugin project. So I'm loading the library. So if it's iOS, then I am loading different the file. And then if it's Android, I'm loading libsum.so. If it's Windows, it will load libname.dll. But actually, this one is not going to work because I didn't compile it. And if you see the Flutter application that actually using this plugin, it's exactly the same thing. I didn't change anything there. So I'm just calling the native underscore add sum function 1 and 2, and then I have the result that I just display. So if I run it, it will be exactly the same application. But you will see. And this version of the example, I compiled for the iOS, Android, and macOS. So you can use it for multi-platform. But if you want to do it for Windows, maybe you need to study a little bit more. Yeah?
I didn't say, everything is synced. There's nothing future or everything is synchronous?
So that is something a little more complex topic. But yes, so if you want to do some function take long time, then you need to spawn the isolate.
Sorry?
You need to spawn the isolate. So it's nothing special, but you just need to use the isolate, and then you make the different thread or process, and you can use it asynchronously. But you cannot just do it with the await. Yeah. And I was about talk after is there's another, the problem is the memory control. So since it's native application, you need to actually control the allocating the memory and then deallocating the memory. So even the Golang automatically manage memory, and then even the Dart automatically manage memory, we are using C interface, right? So if you want to share the memory between the Flutter and the Golang, you have to allocate the memory in C, and then you have to deallocate the memory. So you have to actually manually control it. So that actually I can show you after.
Jhin,
Yes.
you referred native add dot some. Is that a namespace? What is that native add? Is that a import?
Sorry, I didn't understand.
When you define, I think you defined the sum function.
Uh-huh.
You said native underscore add, I believe.
This.
Yeah. What is this?
No, this one is just like the library.
It's the library.
Yeah.
Gotcha.
Yeah. Because this library has the sum function that I told you that just only calling the binding sum function, which is binding sum function is actually bound to the C. So it's calling this C there because he needs to find it in the library where is this function in the memory, right? That's what binding does. So he will call that exact point of the memory, and then you will run it, and then once they have it, you're going to have the result. So you can all do this manually, but it's complex, right? So that's why we use Jhin to automatically does it. So yeah, it's exactly the same application, nothing special. That's about it, actually. It's really simple. And then I can show you, I can just tease you a little bit about the iOS build script. So there's some script that I wrote it. So important part is here. So only difference between the Android and the iOS is you need to give the build mode as archive instead of the shared. And then the extension is different. And yeah. And I also have the make file. So you can do make Android x66, 64, then it will create, it will compile for the Android, and then for the iOS, same thing. So, and the LiPo stuff that I told you, so merging two different, the architecture library into one. So LiPo is provided by Apple, actually. So I wrote the script, just do it automatically. And then the other one is for macOS is the same thing. So you need to use the LiPo, you merge it, and then, yeah. Yeah, the other one is that here, I need to use the Xcode build to create XC framework. So I merge all the library into a package so that you can use in the iOS, basically. All right, that was the demo, actually. So some conclusion there. So like I said, we can load any native library that has a C interface into your Flutter application. So it doesn't need to be Golang, right? So Jhin is there to automatically generate the bindings. With the header file, you have it. So if it's C application, you might need to write this header file yourself. But if it's Golang, if you use CGO, it will automatically generate the header file. So you don't need to worry about it. And yeah, so Golang has the cross-compiling capability. So you can even compile the library for Android or the iOS from any laptop. You don't need to use Windows laptop. You don't need to use Mac laptop for compile the library, right? So once you have the library, you just need to make sure that give it to the Flutter project so that you can use it. But Flutter application, you cannot do that actually, right? Because Flutter application, if you want to build iOS app, you need a Mac. If you want to build Windows, the Flutter application, you need a Windows machine, right? So you cannot actually do that, but I mean, at least you can compile the library in cross-platform. And yeah, there's some things you can try out yourself. So I covered Android only today, and then I teased you a little bit of iPhone and macOS. So you can actually try yourself. What I didn't cover is, actually I didn't cover is Windows and Linux. So Linux is going to be mostly similar to Android, but Windows might be a little different. So I didn't study on that, but basically the same thing. You just need to provide the architecture properly and then compile the library. And in my article, I am covering iPhone, Android, the build. I didn't cover macOS, but I have the example that run with macOS in my actual example. So later, I'm going to share the slide, then you can actually try out yourself with the example I made. And yeah, the question from Ekaras. So WebAssembly. So actually, for WebAssembly, I don't think we're going to use Fusion or FFI interface, because WebAssembly, you compile it to the WebAssembly that you need interface with the JavaScript or something. So it's not going to be the same interface, but this might be great to add if you want to make the covered, the platform covered plugin, if you want to make it. Okay? And yeah, so advanced use cases, we already talked about it. So pointers. So if you want to share the memory, let's say if you want to pass the array and then you want to change the array inside of the Golang application or C application, there's a little bit of complexity. So that's something you need to study as well, how to allocate the memory and how to properly deallocate the memory.
How about threads? Is that something that can be created and managed by FFI?
Your question about thread?
Threads.
Yeah, so thread is different. So Golang has their own thread. Dart application has their own thread, mostly main thread, and then you need to spawn the isolate if you want to use more, right? So what you need to make sure is that when you communicate between two different languages, if the main thread is calling one thread in Golang application, and then maybe you have multiple threads in Golang, right? But you need to make sure this, the thread that you call has to return it to your Dart application. If you return something data from your different thread, it will be crashed. So let's say you spawn on isolate in the Dart application, and then you're calling the native library from that Dart application. You just need to make sure that it's the same thread communication. Yeah, but you can use multi-thread. Yeah, that's not a problem. Yeah.
That would be a headache, but
Yeah, it is. It is.
maybe something.
Yeah, there's some headache. Yeah, you need to control the memory. You need to think about the thread and so on, how to communicate. But the basic is easy. If you want to go deeper, probably more complex, right? Yes.
I'm apprehensive about how you handle dependent. Oh, my voice. about how you handle dependencies within the FFI.
Mm-hmm.
You're addressing specific versions of Golang, and their version specific, version specific compilations.
That doesn't
However,
actually
if
matter.
you have dependencies within your Golang code,
That doesn't actually matter. Whatever the Golang version you are using, you are compiled into the native binary, right? So once it's compiled, it doesn't really matter. But the Go mode file, I just have it because I'm going to use the Golang, whatever the version, on my local machine, just to make sure it's working fine. And then once you compile it, it doesn't really matter. What version you use is compiled. It's programmed.
really, so it's just executes as a binary.
Yeah.
That's very interesting.
Yeah. It's the same thing for the Dart application. Dart application, you can compile into native binary, right? So once it's compiled, no matter the SDK you use, it doesn't really matter. It's just running, right?
So it becomes no less, how do you say, sensitive
Yeah.
to dependencies than writing in Golang natively.
Yeah.
Okay,
That's
very
actually a good point for the Golang application, right? So it always creates the binary. So no matter the platform dependency has, it doesn't really matter because it compiled into the binary that can run, make sure to run on the platform.
Wouldn't that also eliminate the problem of memory addressing? This is why I raised that question.
Golang automatically manages memory like
Yes.
Dart application, so you don't need to worry about the memory. But I mean, it's the same thing. Even Java manages the memory, you still care, right? Even Dart automatically manages the memory, you still care. JavaScript, the same thing. But no hazel because of the Golang, no hazel because of the some languages here.
Okay,
Yeah.
I understand. Thank you.
All right. So, yeah, you have a question?
Yeah, but continue. But
Yeah, for references in my slide, when I share, you can just go through. What I want to especially say is the ESA database. That one is written in Rust with the FFI, Dart. I don't know if you know about ESA. It's the database that can run in cross-platform and in any Flutter application or Dart application. Hmm?
Not on the web.
No, actually it works on the web.
Not the
It's buggy?
Yeah, it's not
Okay.
not stable yet.
Okay, maybe not stable, but actually it's running on the web because it even have the WebAssembly compile. So it compiled the Rust application into the WebAssembly so that it makes it possible to run even on the web, the application. Yeah, and then I put some official document from Google, so Dart cinterop, and then the Flutter cinterop. Yeah, that was about it. On time?
yeah, on time. Okay, I have one question.
Yes.
So you put the binary in the Android part.
Mm-hmm.
Does it mean that FFI Jhin is only a package or a tool just to create the platform channel between?
No, actually,
Things.
FFI doesn't care for the library. It only cares of the header file.
Okay. So how do you put FFI compared to platform channel? What would be? I don't know how to ask the question, but it feels like FFI is different, completely different from platform channel. So we have a different protocol of.
Yeah, it's completely different, yes.
Oh, okay.
Because the FFI, actually, you are loading it in your Dart application.
Okay, that means the binary is kind of like an asset loaded
Yeah.
inside Flutter.
Yes.
Oh, okay. Okay.
I mean, in the Flutter memory.
Yeah, in Flutter memory.
Yeah, in the package is file, .so file or .a file,
Okay, completely different.
or DLL for Windows.
Okay. I understand.
Yes.
Okay, so if I go back to the start of the story, you were doing an experiment with a friend developing in Golang.
Yes.
And what was his feedbacks about what you bring to him with Flutter? What is his conclusion?
I mean, he liked it, but he actually didn't use it because he already did it with the other framework. But yeah, I think before I do this, when you do this kind of study, you're going to start with Google, right? But I actually couldn't find any information actually how to do it properly. So it took some time. So in the meantime, he actually done his project, right? Yeah.
Okay, thank you.
Thank you. Anyone else? Thank you very much.